All right, thank you, thank you, guys. My name is Xinan. I'm presenting Singularity V2. I really like. I also want to repeat what Matthew has just said. Please give us feedback. One of the goals that we're here is to hear about your use case and make sure we're doing the right thing. So please, let us know your feedback. Give us your input that will help shape our roadmap and our prioritization. Meanwhile, from this presentation, I would like you to get whatever you see that makes sense to you. Feel free to grab the idea, copy the code from Singularity, or try it out and use it as a library, use it as an API, or use it as a Docker image. Let us know what you think. OK, so this slide, it's like an introduction of what data preparation means or data onboarding means. Usually, this is the most common case or most naive approach of data preparation, which you convert a file, say your grandma's cat picture, into a car, which is a car file. I'm saying this is the most common way because there are other ways will be covered by other speakers, like from web data storage or from Internet Archive. They're using other ways of doing data preparation. But essentially, when you have a cat picture, you first break it into blocks, add a car header, add some padding, calculate the PCID, which will be including the deal. So that's essentially what it means by data preparation. And you also need to handle cases where there are too many small files, where you need to combine them into a big file, a big chunk. Or if the file is too large, you need to split them into multiple chunks. Deal making is basically making deals to store providers. And once the store provider has the deal, they pop it on the chain, they seal it, and then they submit daily proofs. And final retrieval, you can retrieve files from either Singularity server or store provider, or you can retrieve the car file from them as well. So I'll get into more detail of that in later. So I noticed here, we're saying that when we read from owner data or this cat picture, we know that it's reading from some kind of a source storage. And when we convert that into car file, you'll need to actually store into some kind of destination storage. For example, you want to convert from one local drive of your local file system into another local drive, or you can convert from, say that, our S3 bucket into some car file and stay in your local file system. That concept we're going to be using in our next slide, which will talk about storage system connection, which is one of the main concepts of Singularity V2. In V2, a storage system connection is basically a connection to any storage system, which can either be local file system or S3, including other compliant ones like IBM S3 or Ceph S3, HV site, or 37 other types, which include your grandma's Dropbox. Actually, I'm not lying. To show you, actually, we have like a API, which we want to connect into Dropbox, and also a CLI, which will help you connect to a Dropbox. And as long as you have the client ID, client secret, or the token ready, you can actually connect to your grandma's Dropbox. OK, let's keep going.
Nice.
OK, and each server connection, they can act as like a source storage or destination storage. So source storage is basically those data are for you to prepare, and the destination storage is where you want to save the car files. So theoretically, you can just scan S3 bucket as a source and save the car files into another bucket. Another thing I want to mention is that there's also a push API. So this is more like I want to scan every files in the source storage. However, there will also be cases we want to actually do some kind of, you want to selectively select some files. For example, you don't want all grandma's picture, you only want her cat pictures. So you can use the push API to selectively choose the files from source storage and tell Singularity to actually do the preparation on those files, or when a new file is available. You can combine that with a local file system to achieve something like you want to actually first post a file into a file system and then tell Singularity about it, which is how we integrate with Project Motion or the dstore API. Here, we already said about the destination storage. However, later I'm going to cover that it's possible that we don't need a destination storage. We only need a source storage. We'll cover that later. Next topic I want to talk about is the dataset DAG. So Singularity prepares in a way that is IPLD compliant or Unix compliant because the data source, the concept of data source here is very similar to the file system folder structure, which we already know that is something called UnixFS, which is commonly used in all of different IPFS libraries because like there's a built-in decoder for UnixFS IPLD schema, and it's supported widely. For example, you can use surpass in the IPS gateway to retrieve the inner file of a folder, etc. In Singularity, all folder file structure are maintained in a Unix compliant way. User can also export the DAG and onboard them to the Filecoin SPs. Here, the DAG is basically a snapshot of a folder structure. So different snapshot of files and different version of files can also be retrieved. So this is a dataset root CID, and then it's linked to multiple different subfolder and nested subfolder, including empty folder, and then the folder can link to different file, and each file can also be linked to multiple different versions. So it's possible for user to retrieve a specific snapshot of the dataset or a specific version of a file. Now, this is interesting. So that's something actually quite new, and it's only available in Singularity V2, not in V1, which we call that, not really a good name, but inline data preparation. What it essentially means is that when we are doing data preparation, we know that the car file is essentially same content as on your file. For example, you have a grandma's cat picture, dog picture, play.mp4, feed.mp4. They are actually mapped into those car files. Each block that directly maps to the block in the car file. So we think it's actually quite easy and quite simple. Just if we can maintain the mapping between those blocks, then we actually don't need to actually store the car files anymore. So that's what we call inline data preparation. Essentially, we're maintaining the mapping of those blocks into the database, so we don't need to extra disk space for the car files. And it also saves data preparation time because you don't need the I/O to actually store those car files. It's also possible to do some kind of reverse mapping. So when you can choose to export to car files, delete the original file, and you can also get the original file from the car file. Okay, now we have the data has been exported to car files or inline prepared. We need to think about how we want to distribute the car files to the storage providers. There are majorly two ways. One is we can run Singularity Content Provider, which is essentially an HTTP service which serves the piece retrieval. Piece retrieval means a way to retrieve car files using the PCID of the car file. And because the server backend, it connects to the underlying storage system. When a request comes, it goes to HTTP service. It first it checks the existence of the optional car storage, see if there is already an existing car files there. If it does not exist, it goes to the inline preparation route, which it gets the header, look at the header in the database, get the inline mapping, and then direct stream the HTTP stream from the original data from the original data source storage connection. For example, if this is a Dropbox, then when you get the car files, it's going to stream from the Dropbox directly without having any extra disk for car files. And it also supports multi-threading. Another way that, and in this case, you might think of, let's say we are preparing some kind of an open data set in AWS 3. Then I want to distribute this car file into 10 different SPs. And now the bottleneck, it becomes the bandwidth of your own HTTP server. Because each request will come for your HTTP server, it's limited by your own bandwidth of your egress. How about let the storage provider download the file directly from AWS 3 while they assemble to the same car file deterministically? And that's the idea of Singularity metadata API. Well, essentially, how it works is that you have a download client. First, it tries to get the car metadata from the metadata API. Then it gets the header and inline mapping. With this information, you'll be able to, of course, you can override some configuration, for example, AWS keys. With those information, you'll be able to assemble the car files into the same car file with original data coming from the original data source. In this case, the SP, they can generate the car file directly from AWS 3 with this kind of mechanism. And also it supports multi-threading. Another interesting part is that, say that you are the data owner and you only want 10 different SP, only those SP can download the files from your S3 bucket. You can assign them different AWS IAM raw key and secret, and so that they can be independently revoked if it's possible, if it's needed. Okay, next one. Once we have the car file distributed, now it's time to make deal with the storage providers. This is kind of a very basic ones. The deal making, we support legacy market and boost market. The most common thing we're using is called push mode, which we kind of essentially would define a schedule saying that, hey, all 1,000 deals in one batch, or like if the storage provider already know that their CD capacity is like 20 terabytes per day, that's about 600 car files per day, then you can set a schedule saying, hey, send this storage provider 600 deals per day, or you can do things like 10 deals per hour. And it supports auto-renewal and all boost options. Another way to do the deal making is through something called a pull mode, which is very similar to how Spade does it. By the way, this is still work in progress. For the Singularity user, you only need to define deal making policies. For example, you allow the users to define the constraints. For example, you want to limit number of replicas per PCID, or you want to limit number of min and max of the deal duration and start delay. And then the storage provider can hit the API, get what are the available pieces, and then make self-proposal. Okay, and the final piece is about retrieval. So Singularity supports different kind of retrieval. First, we want to talk about where you want to retrieve from. It's actually a quite important concept, because retrieval, you can think of retrieval from storage provider directly. You can also think about retrieval from Singularity directly. One thing that people are asking about retrieval is that, okay, while we are onboarding data to storage providers, who will be served the retrieval while the data is still being onboarded? Well, because Singularity itself, it actually has all the data itself, so it can serve as a retrieval provider, which can provide retrievals for files and pieces. So Singularity itself, while onboarding data to storage provider, it can serve retrieval. And because it can also publish itself to IPNI, so it can also use Lassi to retrieve the files from SP and from Singularity at the same time, whenever they're available. It's also possible to retrieve from Singularity, actually retrieve from SP through Singularity. Basically, Singularity is kind of a centralized place for retrieval, and it will handle all the SP selection, who has the data, and provide a file stream to the retriever. That's actually how dstore works. Is it integrates with Lassi library to offer retrieval from storage provider via HTTP API. And finally, you can also retrieve from SP directly, and that's kind of a main value proposition of Filecoin because all the data is stored distributed. Because Singularity maintains the the IPLD tag for the data structure, so you can do bitwise retrieval and graph retrieval through bitwise retrieval through IPFS or using Lassi. So whenever you want to do retrieval, you can do IPFS get using the file CID for any version or the folder CID using any version, and it will come from whatever that SP that has that block data. And what?
Real quick, for the from SP through Singularity section, the HTTP API reference there, is that like the graph API that like the Lassi implements that you're fetching by the content CID?
No, it's not. So it's like so actually the HTTP API means the storage provider boost HTTP API. So we actually, when we integrate with Lassi library, we are saying that, hey, just see if the storage provider has the boost HTTP API available. If so, then use that for retrieval. You can retrieve different versions of file. You can retrieve whole directory or the whole data set. You can retrieve file by path. This is possible because everything is Unix FS compliant. As long as you know the root CID, you can do /subfolder/subfolder/file to retrieve file by path. And car files, well, this is basically a piece retrieval. Architecture, I feel like this slide is not that interesting, but one thing to call out is that it's a database-based application. You can interact with CLI, you can interact with Web API, and you can, in the database here, you can either use SQLite, MySQL, or Postgres. So it's very easy for you to get started just using the default configuration, which is a SQLite, and everything is pre-configured. You just need to download the CLI, and you can just start running it very quickly. Final thing I want to talk about is how we integrate with other systems. Because Singularity itself, the goal is that to make it quite modular so that it will be easy to integrate with any system, so you can utilize it for your own purpose. For example, we have our web API defined as a Swagger configuration. So other people, they can utilize this web API and build their own API. For example, you could build your own Azure API, and Marcy and the Bedrock team has been using it to build a distro API. We also have a POC of a web app API, and using that, you can build your own Dropbox-like experience. For example, you can integrate that with OnCloud, Nextcloud, and your grandma will be able to drag and drop his cat picture to Singularity through this API. On the other side, which is the deal-making side, you can use the deal engine of Singularity only by first importing all the car metadata into through the API, and use Singularity deal-making engine to make deals to all the SP. You can also just use the data preparation only and use your own deal-making module. For example, you can integrate with Spade, Delta, S-Jury, CID Gravity, so that you can do data preparation using Singularity, and then do the deal-making with your own platform or with your own software. Okay, so final one is, this is in our roadmap, which is going to be for the next quarter. It's what we are doing like a dashboard for the Singularity users, so we can see all the deals prepared / expired proposed over time, which gives you a high confidence of like the things going on. And one thing about this is that if you're using Singularity for that Motion, you get it for free, because you can use Motion as your API for your customer to onboard their data, and you'll see all those dashboard as a Singularity feature. Same here is like everyone who has uploaded files, you'll see this folder structure and CID. Oh, I think I missed a CID here, but CID of folder and CID of different files. This is a mockup, by the way. Finally, this is QO for sending for updates, and I want to repeat again. The goal is that to make sure you grab your own, you give us all your feedback, try it out, tell us what you need, and see if we are building it correctly, and tell us what you think, and we can iterate on your feature requests, and you can help us to reshape our roadmap and our prioritization. Thanks. Question? D?
Hold on one second, Julian. Akadi's also in the back, but do you mind if he goes and I give you the mic?
This is built in Singularity V2?
This is planned.
This is planned.
Progress, still designing, inspiration. If you have suggestions, we need that.
Any date?
Any date?
Yeah.
Andrew is my work manager.
I would say, I mean, we're shooting for what we can in this quarter. Yeah, we'll see what we get to by November and share more. Yeah, but if you...
I think the answer is we need more feedback about what exactly the UI needs to be. So have these conversations not as part of this Q&A, but offline. And with Xinan, unfortunately, Xinan wasn't able to be here. Based on that feedback, we can then have a more detailed scoping and timeline.
Literally, that is the biggest thing holding us from going faster, is we need more conviction on a few of these things. So if you can provide that, then that would help us a lot.
Should we limit the next round of Falcon Plus deals to people just using this system by making everything transparent?
This is an extremely dangerous suggestion. My opinion, and this is only my opinion, is no, actually. I don't think it's worth coupling this stuff to a single tool, but I do think having higher standards for what we use is a good thing. And so sharing what that means is a valuable and useful next step.
We have been building in the old Singularity for older Singularity version for a while, and we have some partial data sets. When will there be a migration path that you can finish the old data sets in the new Singularity?
Right now, there's only a migration path for completed data set in V1 to V2. With the request, we'll see how we can prioritize that.
Arkady, please.
So this is awesome. In particular, I'm very excited about the header and inline mapping mode. So I have so many questions, but I'll ask just two. So first of all, for the data prep, is it possible to run the actual, that piece separately from the primary server? So could we run it on our data nodes where the data is located so that we avoid copying bytes around needlessly? And secondly, if we do use this mode without the car file, do SPs need to do anything special, or does the main Singularity process assemble the cars on the fly, or the car stream, I guess, on the fly?
To repeat your question, is the first question to run DAC generation in a different machine?
Yes.
Okay, yes. So
It's the same question I asked about V1 months ago, but now this is
so you have
like
a chance,
very
and
useful.
also if you try and see if it works differently, then please make sure we hear your feedback. Right now, I think it's supported. If you see here, so when you run the dataset worker, you can specify that hey, this worker only do DAG generation, so you can run it in a different machine, and it will not it will not impact your other dataset worker runners. And your second question again?
The second question, so if I do use this mode where no car files are actually stored, do the SPs need to do anything special to consume them, or does Singularity take care of that on the client side?
Yes. So right now there's a download utility to actually do a download from the from using the metadata API. We also plan to have like the users can stand by a local HTTP download server so that they can download from their local HTTP server using their favorite HTTP download tool, for example. And that HTTP server will be responsible for talking to the metadata API and do all those inline mapping interpretation. And that's also possible to integrate that with Boost, because you can send a deal to store provider saying, hey, you can actually download your car file from your own Singularity HTTP server, and that will just work directly.
Do you think this design would make it possible for an SP to actually just download the underlying files over HTTP and assemble the car file on their end?
I think that's what we are doing here right now.
Oh, okay, awesome.
Oh, wait, one more thing is that there's a cons for inline preparation is that the data has to be not immutable, kind of immutable. You can't change or delete any data, otherwise it won't work.
So I have a question about the metadata API specifically. Is when you're talking about metadata, are you just talking about automatically generated metadata, or is there a way for people uploading data to add custom metadata that's specific to their system that they want to track on chain, or they want to track with the data set?
I think the metadata here you mentioned is probably a different concept. The metadata I mentioned here is like it's the inline mapping between the original data storage and the car file. What the metadata you're talking about is more about the metadata about the data set. Is that correct? So for that one, it is currently not tracking a database, but you can add another column in the database and say, hey, this is metadata, and do that on your own application. So if you have your own application and you can integrate with Singularity, you can certainly have your own definition of what dataset metadata is, and you can choose your own logic of how you want to expose it to like on the chain. So I'm not sure how that works right now, but that's completely possible.
No,
Can I see the retriever slide again, please? I think it's the next one. Oh, two more up. Two questions in the end. Is this the direct retrieval from the SP unseal tolerant?
So by default, if you don't specify anything, all deals may specify that, hey, we need an unsealed copy. But it's really up to the SP to decide whether they want to delete that copy.
But does the software crash if it needs to wait 8 hours for an SP to actually deliver you some data?
That's true. So
the question is, are you prepared for that? It's very expensive to store unsealed copies. We will see less and less of them.
The unsealing is only triggered by, as far as I know, it's only triggered by graphing retrieval. But usually the retrieval here means either HTTP retrieval or base retrieval. In that case, if the unsealed copy is not there, it will return immediately saying that, hey, I don't have the piece.
Okay. The second question is, we are storing a lot of replicas of the data. Will this at some point be able to fetch data from more than one SP at the same time? If we have 32 gigabytes stored and we store that 10 times, we can pull... Yeah, right. We are decentralized.
So yes, yes, not always yes. If you do base-wise retrieval is basically spanning all the block requests to different. So what it does is at first is query for who has each CID through IPNI. before that, even before that, so usually you want to retrieve a file. A file can have multiple different blocks. First, you get all those block CIDs, and then you kind of broadcast those retrieval requests across the network, including look up the IP9 indexer, say, hey, who has those blocks? And then it will actually look up that and say, hey, it's available from those 10 different SP. Then you'll actually parallelized fetch those blocks from those SP in multi-threaded manner. That's handled not by Singularity, but handled by the BitSwap client if you're doing bit retrieval. If you're doing HB retrieval, no, because HB retrieval, you usually specify an endpoint, and in that endpoint, you will be saying, hey, I only want to retrieve from this SP directly. And in that case, it's only from a single SP.
I have a question that I'm going to ask on behalf of Arkady. If Internet Archive wants to run just the inline data prep for their car files, what are the hardware requirements?
So the memory consumption and CPU consumption is kind of very similar to what the software that you have wrote, which is so we actually did a benchmark. They're almost the same. There's a slightly overhead in Singularity because you have to store the data metadata into a SQL database, right? And compared to the software you have built, it's a CSV, right? So it has a slight overhead here, but the hardware requirement is very similar.
And just to clarify the conversation you just had with Arkady, at the very end, it's that the SP is able to, like, the abstraction to the user is that I just put my file, like, make it available to the SP. It's the raw file, not the car file. And the SP takes it and does the data preparation for you, even constructing the car itself?
That's correct.
Okay, got it. I guess, like, you're putting a lot of trust in the SP in that situation, right? Because you're not creating the CID on your end.
That's right. So
Okay.
do you have a few checks on the client side? One is that when you retrieve the file from the same source, it's going to verify the last modified and the hash. And the hash, it means differencing in different systems. For AWS3, it means ETAG. For other software, it means differencings. But if those mismatch, then you will not attempt to try to assemble the same car file. And also, after assembly, when you import the car files to your post market, you also verify the PCID. So if it's something wrong, then you won't be able to importable.
So that makes sense, and then that also applies to the payload CID too, right? Like you won't know how to fetch like even the first two options on the left-hand side of this slide. Like you're not, until the deal is made, you're not going to be able to fetch your file back, right? Even with this Singularity.
There are two steps. So you run the thing, like you have the payload CID, and correct me if I'm wrong, Xinan, but you have the payload CID, calculate compy, you just don't write out the car file. And you use that to make the deal.
Oh, so okay, you still generate the CID, you're just like, you're not doing any extra data munging. And then like the SP does the work, and then you verify that against what you did locally. Okay, so you're still doing all the compute stuff, it's just not an extra copy of the data.
And also everything is streaming, including doing the compute part, as well as the SP when they actually download the car file from the original data source. It's not like downloading all the files in the local file system and then assemble to the car file. It's downloading the file directly in one stream to your file system.
Okay, we're going to wrap here. Thank you so much, Xinan. Round of applause, please.